Hi there. Today we're going to show you how DeltaStream can help repartition your data using a simple SQL query with partition by. For this video, we'll be talking specifically about repartitioning your Kafka data, but DeltaStream's partition by can be applied to data from other systems that support partitioning as well. Before we get started, let's first talk about how Kafka partitions its data and why you might want to repartition. In Kafka, every record has a key payload and a value payload. When a particular record is produced to a Kafka topic, Kafka determines which partition that record belongs to based on its key payload. So all records with the same key will end up in the same topic partition. If a record doesn't have a key, then a random partition will be chosen. One reason you might want to repartition your Kafka data is to address data skew among Kafka partitions. In this diagram, we can see how data skew might occur. Here we can see a Kafka topic with two fields, UID and PID. Partition 0 is overloaded with events compared to partitions 1 and 2. In this case, our data is partitioned by the UID field. However, UID value of 1 is a bit of a hotkey, causing partition 0 to have a disproportionately large volume of data. Data skew can present problems for the Kafka brokers. The Kafka brokers responsible for partition 0 will need to spend many more resources to handle its workload, which can result in running out of disk space and slow I/O operations. Meanwhile, the other brokers will likely have extraneous resources that are costing you, but are underutilized. Data skew can also affect downstream applications. Kafka allows at most one consumer per topic partition. If an application was trying to consume from this topic with 3 consumers, then each consumer would be assigned to one partition. The consumer that is assigned partition 0 will have a much larger workload. This can become challenging for things like stateful event time processing, because the consumer for partition 0 won't be able to keep up with the other consumers. If our example Kafka topic was partitioned by the PID field instead, we can see how the spread of data is much more balanced. Each of the partitions has a much more equal workload. Another reason users might want to repartition their Kafka data is to align the data according to its context. In this diagram, notice that we are partitioning our data based on the value of the UID field, but let's consider that we have a downstream application that aggregates based on the value of the PID field. If we were to parallelize our stream processing job, it would look like this. Each consumer would read from a single partition of data, but it would then need to shuffle each record to the correct aggregator task. This is additional network and I/O operations, which can be expensive at scale. Here is what our diagram would look like if our Kafka topic was partitioned by the PID field. Here, each aggregator task can get all of its records from a single consumer, skipping the need for the consumer tasks to shuffle records to the correct aggregator. Since we know how our data will be processed, we can partition our data accordingly to create a more efficient stream processing application. Now that we have some understanding of our Kafka partitions data in their topics and why users might want to partition or repartition their data, let's see how we can achieve this in DeltaStream. While DeltaStream has a great web UI, today we'll be switching it up and showing off the DeltaStream CLI. Here in our DeltaStream organization, we already have a Kafka store defined. We can list my stores with the list stores command. To see the topics in this store, we can use the list topics command. Here you can see a topic called page views. Let's print this topic to see the contents. Note that there is no key defined for this topic. We can create a stream for the page views topic by writing a create stream command. This stream definition matches the contents of the underlying Kafka topic. Now with our stream defined, we'll write a query that will rekey this stream and write the results to a new topic using the partition by clause. In this query, we are selecting all the fields from the page views stream we just created and writing the results to a new stream called page views keyed. Notice in the partition by clause that we are partitioning by the PID field. This will set the PID to be the key for the resulting records in the sink. By submitting this statement, a long-lived continuous query is launched by DeltaStream. We can check on the status of this query by listing our queries. It takes a few moments for the query to transition into the running state. If we list our store topics again, we can see that a new topic called Page Views Keyed has been created by the query. We can inspect the new sync relation we just created using the describe stream command. Notice in the metadata, the key type is PID, which matches the partition by clause from our query. Also, we can see that the topic backing the stream is page views keyed, the one our query just created behind the scenes. Checking on our query again, we can see that it has transitioned into the running state. Now, if we print the sync topic, we can see that the records are keyed by PID. In this video, we started off talking about how Kafka partitions data in topics and discussed some scenarios where Kafka users may want to repartition their data. Then we showed how using DeltaStream, we can easily rekey a Kafka topic with a single query using partition by. If you want to give DeltaStream a try for yourself, a link to a free demo is in the description below.